Sorry, we got cut off. So I was adding C2 times cosine beta x minus I sine beta x. Okay, so the next thing we're going to do, this has to distribute to both of these. This C2 has to distribute to both of these. Okay, I'm going to pull this first one, the C1 e to alpha x cosine beta x, and then the first part of this one, C2. Oh, I forgot my e to the alpha x here, sorry. That should be plus C2 e to the alpha x. That's in both. Okay, that came from here. C2 e to the alpha x, and then this thing replaced this from the other page down here. E to the negative I beta x was this thing. Okay. So if I take this first part and this first part, both of those have an e to the alpha x cosine beta x. So I've got y equals, and then I've got a c1 plus c2 because the c1 and the c2, after you factor out the e to alpha x cosine of beta x, okay, and then I've got plus, now this one, the second part of this one and the second part of this one, both of them have an e to the alpha x I sine beta x. So I'm going to take out the I. I'm going to end up with the C1 minus C2 because this one is going to be negative. C1 minus C2. I have e to the alpha x sine beta x. Now, our new constants, just to simplify, because this entire thing, it gets rolled up into another constant. This, including the I, gets rolled into another constant. So this we're just going to call it C1. Even though it's not the same C1 as this C1, when we add them together, there's our new constant, e to the alpha x cosine beta x plus C2 e to the alpha x sine of beta x. Okay, so just recapping. When you solve your characteristic equation, okay, if M1 and M2 are real and distinct, this is your general solution right here. If M1 and M2 are real but non-distinct, meaning they're the same value, this is your general equation. And if they're complex, imaginary, then this is your general equation. Okay, so now we're going to do a couple of examples. Okay? And we're going to come back and refer to this based on our three cases. So in the book, you've got an example, and this is much easier to use than the actual proof of what we just went over, why it works. So example 2 in the book. Okay, so you have y double prime minus 4y equal to 0. Remember, our general equation is y double prime plus ay prime plus by is equal to 0. Okay, so there's no y prime, so the a is 0. So the characteristic equation ends up being m squared minus 4 is equal to 0, which is m squared equals 4, or m equals plus or minus 2. Okay, so that means m1 is 2, m2 is negative 2. These are two real and distinct solutions. So going back over here, we're just going to plug in our two m values here and here. Okay? So looking at this equation, we get our solution's going to be, looking at this, y equals c1 e to the 2x plus c2 e to the negative 2x. And that's our solution. That is the general solution to this differential equation. Okay, let's go to the next one, which is going to be example 3 in the book. Okay, y double prime plus 6y prime plus 12y is equal to 0. Our characteristic equation is going to be m squared plus 6m plus 12 equal to 0. So you get m. Oh, that doesn't factor. Okay, so we're going to get m equals opposite of 6 plus or minus square root b squared 36 minus 4 times 1 times 12, so minus 48 all over 2. So you get negative 6 plus or minus, that's going to be square root of negative 12 over 2. It's going to be negative 6 plus or minus 2I rad 3 over 2. So you get m equals negative 3 plus or minus I rad 3. Okay, so alpha is going to equal negative 3. Beta is going to equal rad 3. Okay, so now we'll go to this right here. These are imaginary solutions complex, so we look at the one down at the bottom. We're going to plug in alpha here and here. And then we're going to plug in beta here and here. Okay, so we get y equals c1 e to the negative 3x cosine rad 3x plus c2 e to the negative 3x sine of rad 3x. That is our solution. The general solution. And we're going to go over example 4, which is y double prime plus 4y prime plus 4y equal to 0. The characteristic equation, m squared plus 4m plus 4 equals 0. So you get m plus 2 quantity squared. M is going to equal negative 2, which is non-distinct. Okay, so that was the second case in the middle. So we're going to c1 e to the mx plus c2 x e to the mx. Right? So we're going to get y equals c1 e to the negative 2x plus c2 x e to the negative 2x. Okay. And one final example is going to be another sheet of paper. Okay. Example 5 from the book. Okay, example 5 from the book is actually third order y triple prime minus y prime is equal to 0. And we're going to see here is the same ideas apply here. Okay, so the characteristic equation is going to be m cubed minus m is equal to 0. Factor that, m squared minus 1 equal to 0. So m times m minus 1, m plus 1 equal to 0. So m equals 0, 1, and negative 1. Okay, so we're going to follow the same format, but instead of there being 2 terms, there's going to be 3 terms. Okay, so you're going to get y equals c1 e to the 0x plus c2 e to the 1x plus c3 e to the negative x. Okay, and here we can simplify since e to the 0x is just 1. We call it y equals c1 plus c2 e to the x plus c3 e to the negative x. Okay,